And this video is Unit 3, Section 5, all about writing quadratic equations. Section A is just writing quadratics given a point and the vertex. So I want to write an equation of a quadratic given the information. So it gives me the vertex, which that should be in parentheses, and it gives me a point, just a random point on the graph. Okay. So notice the notes section right here is very short because there's really not a whole lot to write, but if you forgot vertex form, that's what I'm going to be using on this one because it gives me the vertex. I want to use that. Vertex form is just simply y equals a parentheses x minus h squared plus k. Alright, so that's all I need for my notes. That's what I'm going to use. That's the only formula you have to remember. And because these are going to be all functions, they're all going to be y equals. So we're not talking about parabolas. Parabolas are just the shape which can go up, down, left, or right. These are quadratics. Quadratics are a type of function, so they can only go up or down. That does make it a little easier because then we can only use y equals. So we only have one that we have to worry about. We don't have to go back and forth anymore. Alright, so the first thing, I have my vertex. Of course, my vertex, if you label these, are h. I want them to be red, so h, k, and my point, whatever point it gives me, is always x and y. Okay? So here's what I'm going to do. I'm going to take those four letters, those four numbers, and I have my equation y equals a x minus h squared plus k. Alright? Notice I have, of those 5 letters, I have 4 of them. I can plug in 4 of them and solve for a. That's all I'm doing on this part. All I need is a, and so I plug it in, solve for a, and I'm done. I mean, I got to write it in my equation, but yeah, I just got to solve for a. So I'm going to go ahead and write this. So y, notice y is 5. So I have 5 equals a is the only thing we don't have. Alright, x is also 5 on this one. Okay, h is 1. So remember, you always flip h. So if h is 1, here it'll be minus 1. And then k is negative 3, so minus 3. Okay, now I can simplify everything, move stuff around, solve for a, and I'm good. Alright, so I'm going to go ahead and just go in order, like with PEMDAS. So I have 5 minus 1 is 4. Okay, then 4 squared is 16. So I'm just going to put the number in front of a because that's what you would do. And now you have 2 steps to solve this. So I would add 3 to both sides. So I have 8 equals 16a, and then divide by 16 on both sides to get a. And then 8 over 16 just reduces to 1/2, and that's a. Now, here's what I got to do with a. All I needed was a, and I need h and k. Okay, so I don't need x and y anymore. Those don't matter. So all I need is vertex and a. So I'm going to rewrite this equation using just the a, h, and k. Alright? So now, I want y equals a times x minus h squared plus k. So I'm going to replace a, h, and k. And just remember, h always flips sign, right? You always change it. So my final answer would be y equals a is 1/2. And then h is 1, so minus 1. And k is minus 3. And that's my answer. So I plug in what I have, solve for a, and then just write my equation with y equals, and all I need to replace is a, h, and k. I should always have y and x because that's an equation or a function. And that's all my answer is. So let's look at number 2. Number 2, it gives me a graph, but I'm going to go ahead and do the same thing. Okay, I have a point, or I have my vertex right here. Here's my vertex. This is -2, 1, right? and that's h, and that's k. And then I just have to pick any point on the graph. It doesn't matter where it is. So I'm going to go ahead and pick this one right here because that'll be the easiest. That point is -1, -1. And of course that's an x and that's a y. So I'm going to do the same thing I just did because now I have the same information. I have an hk, I have an xy. I plug it in, solve for a. So I have y equals a x minus h squared plus k. And so now I have y. Y is -1. No, what am I doing? Equals. Equals, I don't know a. My x is also -1. Now those don't always match up like that. They just happen to on these. So h. So notice h is -2, so I'm going to flip that and do +2. You always change h. And k is 1, so positive is +1. And now I solve for a. So -1 equals a times -1 plus 2 is just 1, right? So that's pretty easy. Plus 1. 1 squared is also 1, so I'm just going to have 1a plus 1. Or if you don't want to write the 1, you don't have to. I can just do a plus 1, same thing. And so, of course, to solve for a, I just do -1 on both sides. So that'd be -2 equals a. Okay, so now in here, I only want my a and my h and k. And so I can rewrite my equation. So I have y equals a x minus h squared plus k. And so my final answer is y equals a is -2, x, and then h is -2, so I'm going to flip it and do +2 squared, and then k is +1. And that is my final answer. And that's it. So I think both of these are fairly simple because I'm just solving for a letter, which hopefully by now you're pretty good at. You've gotten a lot of practice. But yeah, that's it for A, section A. So let's go down to section B. So now we're going to write quadratics given a point and the x-intercepts. So on this one, the only thing that I need to know, again, the notes section is not very long because I'm just going to have intercept form instead of vertex form because I'm not dealing with vertex anymore. I'm dealing with the intercept, the x-intercepts. So my intercept form is y equals a x minus p x minus q. And if you remember that, great. If you don't want to write this down, you don't have to, but this is just so it's here. You don't have to go looking for it somewhere else. Okay, and then of course if you don't remember from before, my x-intercepts, when it gives it to me, I should have two, right? So my first one is going to be p, 0 and q, 0. Man, okay, q, 0. There we go. And remember that whenever you plug these in, just like h from before, you always want to change the signs of p and q. If it would quit moving around like that on me, that'd be great. So change the signs of p and q when you plug them into this equation. Alright, so that's all we're going to be doing on here. And again, it's kind of the same thing. We're plugging in our p and q, we're plugging in our point, and we're solving for a. So all of these are just solving for a. So if you want to label these, my x-intercepts is p and 0, q and 0. Well, actually, I don't even need the 0. I just need p and q, and then my point is h, or am I, wow, so I'm thinking in vertex form. My point is x and y. Alright, so I have p, q, x, and y. So let's look at my equation that we just did. Y equals a parentheses x minus p, x minus q, and now I'm going to plug in everything that I have. So notice I have y, I have x, and I have p and q. Alright, and remember to switch the signs of p and q. So y is 24 equals A I don't know. So X is 3. And the first P is, or P, I guess there's only one P. So P is -1, so I'm going to put +1. And then X again, so I'm going to have X twice, that's okay. And Q is 5, so it'll be -5. So now I just have to solve this to get A. So I'm going to do the parentheses first and go from there. So 24 equals A times 3 plus 1 is 4, and then 3 minus 5 is -2. Okay, I'm going to multiply those together, so 24 equals 4 times -2 is -8A, and then divide by -8. So that would be -3 equals A. Okay, so just like the last one, once I find A, all I need is A, and then P and Q, and that's it. So I'm going to go ahead and write y equals A, x minus P, x minus Q, and now I'll replace A, P, and Q. So I have y equals A is -3, x, P is -1, so I did +1, and then Q is 5, so -5, and that's my whole answer. And that's it. Pretty easy. Okay, now on 4, I'm going to do the same thing. Same thing as I did above with the graph. So the first thing I have is my X-intercepts. There's one of them, there's the other one. So P and Q, it doesn't really matter which one's which. So I'll say P is -2 and Q is 4. So I have P and Q. And then, just like on number 3, I just need a point. It doesn't matter which point it is. Any point will do. So if I'm looking at this one and I'm going through my line, really the only point that I have is right here. And so that point is 1, -3. And that is my X and my Y. So I have P, Q, X, Y. I can do the same thing I just did. So I have Y equals A, X minus P, and then X minus Q. And so Y equals, I'm sorry, not Y, I gotta replace Y. So let's see, what is my Y? -3. -3 equals, I don't know A. My X is 1. And remember, I gotta flip P and Q. So P is -2, I'm gonna do +2. And then X is 1 again. And Q is 4, so I do -4. And now I solve for A. So -3 equals A, I don't know. 1 plus 2 is 3, and then 1 minus 4 is -3. Okay, I don't know why I did that. So then I multiply those. 3 times -3 is -9A, and divide by -9. So 2 negatives make it positive. 3 over 9 reduces to 1/3. And that's A. So again, once I find A, all I need is A, whoa, not what I wanted, A, P, and Q. Okay? So I have, whoa, quit moving. So I have Y equals A, X minus P, X minus Q. So then when I replace those, I have Y equals A is 1/3. And then P is -2, so +2. And then Q is 4, so -4. And that is my final answer. Okay, and I know there's a section C on this part, down here, but I decided not to put this on the test. And you notice how big this box is. It is a lot of work. And it's pretty much a system of equations with 3 equations using elimination and all that. So because it's not on the test, I'm going to go ahead and skip it on the video. You can always look at my notes to get it if you'd like, but just know that it's not going to be on the test. So I wouldn't worry about practicing it. I know it's on the homework, but again, you can feel free to skip this. This is kind of like an extra thing that I just kind of cut out. So All you got to focus on for today is the writing from a point in the vertex and writing from a point in the intercepts. And that's it. So we are done for the notes.